Probability and Statistics, Normal Distribution, Part 3. This is the third in a set of 4 videos on this channel on the normal distribution. It's worth looking at the first 2 if you haven't before you have a look at this one. This one deals with other normal distributions and adaptations to the use of the Z table. The first 2 were involved with the standard normal distribution. Now we're going away from the standard normal distribution but still using the Z table. So, reminder that we can represent the standard normal distribution by writing N0, 1, where 0 is the mean and 1 is the variance of the standard normal distribution. The area under the standard normal distribution is 1. But of course, we don't want to be tied to a normal distribution with mean 0 and standard deviation 1. And on the other hand, we cannot have a Z table for every normal distribution under the sun. We can't do that. So we work out a way, there is a way to relate it back to the Z table for the standard normal distribution. So there's any normal distribution, n mu sigma squared. X is the random variable, mu is the mean, and the variance is delta squared. Take note that the variance is the standard deviation squared. Where the x values are converted to z values, the standard normal values, the process is called standardizing because we are changing from a normal distribution to a standard normal distribution. So before in the standard normal distribution we used uppercase Z, now we're using uppercase X, but we're going to convert X to Z. So there's the magic formula. Z is equal to X minus mu over sigma. Value of the original normal distribution, the X. Mu is the mean of the original distribution, and sigma is the standard deviation of the original distribution. So in this case, we have to find the probability that X is greater than 65. Notice we've been given the mean and the variance. So the standard deviation is 10. So now we're going to standardize that value of 65 before looking in the Z table. (1.5) using the formula. So Px greater than 65 is the probability that Z is greater than 1.5. So we've used that formula to convert the 65 to 1.5. So there we are. We want this area here. Now remember that the Z table gives us the area from 0 to that value. So we're going to say 0, 5 being the area of that half of the normal distribution minus whatever the Z table gives us for this one. And there is the probability that X is greater than 65. Example, the wages at a large company are normally distributed. The mean wage is 2,000 per week and the standard deviation is 250 Rand. Find the probability that a person at the company earns between 2,000 and 2,500 per week. Interesting, it's now an application to real life. What is the probability that an employee earns less than 1,675 per week? What percentage of the employees earn between 1,737 Rand 50 and 2,250 Rand per week? So there is our conversion. So mean wage is 2,000. So therefore, Z2000 is 0. 2,500, so that's actually the 0. 2,500 we put into the formula and we get a Z value of 2. So now we need, because it's between 2,000 and 2,500, it's now going to be between 0 and 2, which is the straight Z table. There we are, 0,4772. So the probability that somebody at the company earns between 2,000 and 2,500 is 0.4772. What's the probability that an employee earns less than 1,675 per week? So now we're going to convert 1,675, x minus mu over sigma, x minus the mean over the standard deviation, which gives me negative 1,3. So there's negative 1.3, and we're looking at less than, so we have to use the symmetry of the normal distribution to look at Z greater than 1.3, which is going to be a 0.5 minus this area. So there we are. Probability that somebody earns less than 1,675 is 0.0968. What percentage of employees earn between 1,737.50 and 2,250? First thing we do is we convert that to Z scores. So from there to there, by symmetry, we can take this here. So it's that section plus this one. There we are. So we have, only look at the right-hand side of the curve. It's that gray area to 1, and it's the red area to 1.05. Gives you that full gray area. So that means if it's 0.6944, 69.44% of the employees earn between those two values.